Hello, hello. All right. I'm here to talk about our build pipeline for Nitro Enclaves and how we basically make reproducible images, right? Fair warning, this is going to be a fairly technical talk. So let's jump right in and first see what's like the expected pipeline that AWS expects us to use. So you basically go and install Nitro CLI. You build a Docker image that has your application in it, and you then use Nitro CLI to basically build an Enclave image. Pretty simple, right? Let's get to the problems. First off, Nitro CLI doesn't really install well outside of EC2. You just get errors when you're installing. But turns out that it doesn't really matter. Even though you do get error, you can still just use like the half-broken installation of Nitro CLI to build images. You just can't run images. And Docker, of course, works just fine. The next problem is when you go to build a Docker image, which obviously works, as we all know. But it's really hard to make a Docker image reproducible because Docker adds a lot of like metadata about your system into the final image. And there's also the concern of what do you do if you actually want to install Docker and use Docker inside your image, right? You quickly get into a lot of like shenanigans around trying to do Docker in Docker, which is again nearly impossible to do outside of the official images. And personally, I've never really gotten it to like work fine with Nitro Enclaves. The last step is, of course, building an enclave image, which kind of works. The problem, again, is that it's not really reproducible, for one. It also includes a lot of metadata about your build system and all that into the final build. And it also doesn't really support enclave images beyond 1 GB. And that's just a limitation, hardcoded limitation in the Nitro CLI. The problem is that it basically relies on this repository called like AWS Nitro Enclaves image format, right? And this basically includes a lot of metadata about your system into it, and there's no way to just turn it off. It's like a compulsory part of every enclave image. So before we try to get into how do we make this like process all reproducible, let's probably first get into what we are actually building in the first place, right? So at the end of the day, what we want is this, what's called as an enclave image file. So it's basically a binary blob that looks something like this. So you have an EAF header that has a lot of details about the EAF itself. For example, default CPU, default memory, some checksums, number of sections, like offsets and lengths of each section and all that. And none of that is important. Just forget about all that. So what's really important are these sections that you see over here, because the sections are basically what contain all of your code and the kernel that's actually going to execute inside the enclave. The most important field is the section type. And as you can see, we have like 6 types over here. And the most important type over here is the ramdis section. So this is what actually contains the stuff that's going to execute. There are 2 different like ramdis sections, one for the system and usually one for the user. You could have multiple, but it's usually just one. The system has the Nitro Secure module, which is what actually makes Nitro Enclaves an enclave. It also has like an init program. That's basically what runs when your kernel boots up. And the system init basically contributes to PCR1, or I guess the equivalent would be like an RTMR for TDX, right? The PCR1 also includes the kernel, which is like the second section that you see over here. And there's also a user init that contains the user applications that you are actually going to build and package into the image. And all of that goes into PCR2, right? So at the end of the day, if you want a really good reboot attestation process with like predictable PCRs, you need to make this entire process reproducible. Because without that, you have no real way of like computing PCRs yourself and like verifying what's actually running on an enclave, right? So let's just summarize a little bit based on what we have above. To make the final enclave image reproducible, we need all of this stuff to be reproducible. The obvious one is, of course, user applications. The stuff that you're going to put into the enclave has to be reproducible. Second one is the kernel that's running inside. That has to be reproducible. We also have the NSM, the Nitro Secure module. We have the init binary that's going to like start up your entire program. We also have like metadata that we have to put in there, which is the last field over here. And this is a compulsory field in new enclave images. You just can't leave it out. So we need to make that reproducible. And like usually reproducible metadata basically just means you just hardcode some fake values in there and move on, right? So apart from that, we actually need to build the enclave image as well. And to do that, you're going to have to use the image format repo. And so you need image format itself to be reproducible. And you also need to package everything up into a format that it can understand, right? So let's go one by one. First one is how to make your own applications reproducible. But unfortunately, this is just something you just have to go and do it yourself. Mainly because it's very much dependent on your application and like your stack and how it all works, right? For us, we use a mixture of like Nix and Docker-based builds, and happy to elaborate if you guys want. But yeah, this is something you're just gonna have to figure it out for yourself. The next one is the kernel, NSM and init. These are actually all in the same repository by AWS, and we essentially just build our own artifacts reproducibly using a custom pipeline. But for some good news, AWS actually updated their Bootstrap repo to be entirely Nix-based, so you don't really have to do any of what we do. You just clone the repo, build it using Nix, and it's just all fully reproducible by default right now. So that's good. The next part is the metadata. It's computed inside the image format repo, but there's no real way to change it. So unfortunately, you're going to have to fork the image format repo and just comment out where it computes it and just hardcode your own metadata, which is kind of bad. But again, improvement over here. Turns out AWS updated the repo, so the metadata can now be passed in as like CLI parameters. You won't really need to fork anything. Just call it with whatever fake metadata that you want, and it'll just work, right? So yeah, that's good because we don't really have to fork anything, except we kind of do. Image format is a Rust-based repo, and somehow AWS didn't push a cargo log file, which means none of the dependencies of the repos are like pinned. So issue has been opened. Hopefully they'll fix it soon. But the state today is that you are unfortunately going to have to fork it and like maintain a log file yourself. Now, the last part is packaging. The way image format works is it basically converts like Docker images into enclave images, right? And what it wants is not exactly Docker images, but it wants like archives which look like Docker images. So the easy way to do that is you get something like Nix, which builds everything reproducibly, and it has a nice Docker build image function inside. You can just use that. It'll just output a Docker archive that you can just pass on to like image format, right? And to bring it all together, the repo that basically kind of started us on this journey was the Nitro util repo by Monzo, which basically implements this exact thing above. So it's a Nix-based pipeline, which uses build image internally to sort of like output an enclave image at the end. So to round it off, the build tooling that I just described pretty much exists in like examples and readmes in our GitHub. It's not really documented anywhere, so that's something I have to do. Something that I wanted to look into is like, could we just Nixify everything instead of trying to mix and match like Nix and Docker and this and that for reproducible builds, right? The good thing is that gives you is that you basically run one Nix command and it builds everything for you from scratch. You don't have to do anything, install dependencies, nothing, right? And the advantage of Nix and the reason why we even went that route was it seems to be possible to sort of like extend it to cover like other enclave flavors as well. For example, we just got NixOS to work in TDX. It's something we'll release after we sort of like minimize the OS and like kernel footprint. It's still like hundreds of MBs now, right? So yeah, that's about it for my talk. Thank you.